Hey everybody, welcome to our first lab. It's, as always with these online labs, it's a bit of a work in progress, but nonetheless, I think we'll see how we go. We'll make do. This week, I have a reflection simulation for you to work with. So the goal of today's lab is to get you to, again, practice the ray diagrams for the mirrors, and then take a look at a online ray optics simulator and make the simulator show the rays, and then you can compare the rays from the simulator to your ray diagrams. And then also we're going to actually take some calculations, do some predictions, and then see if the simulator is matching what the math and our ray diagrams are telling us. So the lab this week looks like this here, and what we're going to do is we're going to use the simulator, which is this at this address right here. So we're going to start off with a plane mirror, we're going to go to a converging mirror, we're going to go to drawing some ray diagrams and doing some conceptual interpretation. We're then going to do some measurements and compare the predicted value to what the simulator value looks like, and then we're going to do that again with the diverging mirror. Alrighty, so if we take a look at the simulator itself, if you were to click on that, you would come to this page here. And so the first thing that I would suggest is just kind of looking at the menu and understanding what this is. I remember the first time I looked at this, it was kind of like, whoa, what is going on? So first thing to do is go ahead and set up a grid. That's really useful. That way you have a good reference for verticals and horizontals. The little magnet right next to it does not actually create a magnetic field, which I was bummed to find out, but it is a useful thing, which is snap to grid, and every now and again that is useful, but right now we're gonna leave that off. So what I would suggest here is that we go ahead and set up a ruler. A couple of rulers are going to be really useful. Now I'm gonna, in fact, begin before I do the ruler. I'm gonna go set up a plane mirror, and they just have you draw it, so I'm just gonna sketch a plane mirror here, and this probably would have been one of those where snap to grid would have been useful. Oops, because look at that, I messed it up. Alright, we're just gonna drag this over. So what you'll notice is that when you're in the middle of something, you'll get the move around arrows, and when you're at the ends, you'll get the move that end. So you can take the end and and do all sorts of fun things, make it bigger, make it smaller, that type of thing. So that's a pretty useful little tool there. Okay, so I'm going to have the mirror here, and now what I'm going to do is I'm actually going to set up a couple of rulers after I've drawn the mirror. So the ruler does the same basic thing as you just saw. It starts where you start and you draw it. So if I want to measure from the mirror, I can just draw like a backwards ruler that way, and then I can draw a front facing ruler this way. Now this is where snap to grid comes in kind of useful. So if I click snap to grid, what I'm going to do is I can go in here and just move that ruler, and I can also take the ends of it and make sure that it's going to go onto the ends of the grid like that. I'm going to take this one, do the same thing, and I think, did I? Alright, we're going to do that, and then we're going to do this like that. So now I've got the zeros lined up, I think, with the mirror, which looks like that, I think. Let's just make sure. So every now and again, yes, you see, I didn't have the ends directly on the grid line right there. So Just moving it wasn't quite enough to get it perfectly aligned. Not that we're worried about that level of precision with this, but there you go. It's apparently available. So I got the zeros lined up with the mirror. I'm going to do one more ruler, which is going to be a vertical ruler, and I'm going to do that up here. And oh, I already took off my snap to grid. Well, that's okay. We're just gonna hold this over in reserve over here. Now notice every time you create something, this menu comes up right here, and it's got the delete. So if I didn't want that, off it goes. If I want to actually put it back, is that the one that I push, or I can just do Control Z and that works too. Now that nothing is selected, there's no one of those little menus, right? If I put that there, you can change some of the properties of it. Oops, and now I started drawing one and I don't want it, so I'm going to delete that. Alrighty, so now I've got a mirror, and I've got my ruler set up, so I'm going to go ahead and hit it with a light source. We have the option of the single ray, which I can start by going like that and then saying, okay, where do I want it? Right, you see I have a small dot where my arrow is, where my mouse arrow is. It's telling me the angle of the single ray that I want. I have that. We could instead use a beam, and you can draw yourself in a pretty groovy beam of light right here, like that. That's all parallel rays. Okay, and you can shift it off like this. I just want to point out, notice also that the other side of the mirror is also a mirror. So you can use one side or the other, whichever suits your fancy the best. Point source, you just do that and it pops up like so, which is kind of busy, and you can reduce the ray density here with the ray density counter. That would be not reducing the rays. Reducing the rays might look like that. Okay, like so. Now I'm going to get rid of this, and they have one other option, which is just a point source with fewer than that light rays on it. What was the thing I was just going to show you? Oh yeah, if you go over here to settings, no, that's not what I want. What do I want? Oh, it's right here. Here we go, extended rays. So if you go to, not settings, if you go to the view, this little interesting view thing here, the second button, if I click that, then you'll notice that when I do something like a point source, I'm going to put a point source here. I'm actually going to, well, no, I'll just put a point source, say right here. Okay, now you notice that you're getting the tracebacks. Okay, so when you click extended rays, you're going to get the tracebacks of the diverging reflected rays. Right, so that's going to be super useful, because ultimately what that means is I'll be able to measure the image distance. Right? Oops, I was shaking that. That's the object. This is the object distance, and then the image distance. Okay, using the rulers. And the good thing about this is that you can just take them right up here and put them right there. And if I line that up with that, or I could pop my snap to grid back on, and if it's not quite there, I need it here. Okay, so I can get a good handle on where the image is because of the convergence of those rays. Alrighty. So the first part of this lab is to set up a plane mirror and do some predictions of the image distance and the image height, or say using the magnification, and then the last question on about how big would a mirror have to be such that you could see your entire height. So let's take a look at how to do that. Now what I'm going to do is dump that, and I'm going to set up this thing. So objects are easy to set up using a blocker. Okay, so if I just choose the line blocker here, what I'm going to do, I'm just going to snap it to a grid, and what I'm going to do is make it 100 units tall, like that. And I'm going to set it at 500 away from my mirror. And what are these units? I don't know. So in the lab, if you're just dealing with units, we're just using these. I don't know what these units are. They're just units of numbers on a screen. So they're not like centimeters or anything, but whatever. So now what I can do is I can simulate this blocker as an object if I take a point light source and stick it right on the very top of that thing, say right about there. Okay, now I note that the lower end of my blocker is on that line right there, so the height of my object is 100. It's these 1, 2, 3, 4, 5 grid lines, right? So then you're going to go over here and you're going to count. Okay, well, from where the lower part of the blocker was, 1, 2, 3, 4, 5. Is that what we were expecting? Okay, that's our image height. So what are we calculating for the magnification for something like that? All right. So does that work with what you are expecting, and does that work with what the math is telling you? All right. So and we'll use this technique in a couple of other parts of this lab as well. All right. So right now I'm going to take that away just so we get a little bit of respite from the light here, and then we're going to go to using a focal point, finding a focal point of a converging mirror. So we're going to delete this plane mirror segment, gone. Now we're going to go to the circular arc. Okay, so you're going to draw yourself a circular arc. It might take a couple of times to get this something that you're looking for. So something pretty shallow in terms of curvature. Right? You don't want something like this. This is not what we're looking for. We're looking for something a little bit more like, like say that. Okay, I think I got it there. Okay. The reason it might take you a couple of times is because we have to kind of fool around a little bit with the sizing of this thing. This is not a particularly useful mirror for us because you can see it's slanted. But I can take the ends of it and kind of move it around a little bit like that. And if I snap to grid, which I did, I'm going to move that back. I can actually take this down a little bit and shallow out the curvature a little bit. You see, the snap to grid really helps with this one because now that's actually a reasonable mirror. And I can move it to right there, which appears to be my 0 point. Okay, so what we're going to do, actually this is not where I really want the mirror right now, but I'm going to move it way over here for a minute. To about there. What we want to do now is test to see where the focal point of this thing is. Okay, so I'm going to grab a beam. I'm going to set it up right here, and we're going to say, aha, if I just shine this in here, okay, I can find where the focal point is. I can also drag a ruler over there to find out, okay, how big is the focal point, and in this case it looks like it's 250, 60, 70, 80, maybe it's between 270 and 280, I think, right about there. I don't know, I'd maybe call it 275. Okay, so you can measure the focal length using the beam. Get rid of this, and now we will go to a point source. I'm going to do a point source as far away on the other side of the screen as I possibly can. I'm going to increase the ray density because right now only one is hitting my cute little mirror over here. So let's just pop this big. Oh, right, because I got the blocker in the way. Very good. Let's just move this out of the way for a minute. All right, now I got about 4 rays hitting the mirror, and I can once again go through, grab my ruler, measure this focal point, right? Do we think the focal points are going to be both pretty similar? Are they going to be different? What are we expecting? Is one a better than a better measurement than another? What, right? So kind of go through there. These are all questions that you'll find in the lab. Go through and figure out about how far away they are from each other by using a percent difference. The percent difference typically is the difference between the two, absolute value, because we don't care about negatives in this case. And then you divide that by the one that you think is the better representation. And if you can't decide between the two, then you just divide by the average of the two. Okay? So we're going to say that's how you figure out the focal length of your mirror. Now you're going to use this mirror for pretty much the rest of the lab, so keep it handy. Let's see, go back to this thing and get rid of that, and scoot this back to here. And if you have, I don't know, accidentally deleted it, Control Z is your friend. Also, you can go down to here. At the very bottom right, you'll see there's a question mark. If you type that, then it tells you there's a bunch of other things you can do, shortcuts, doing this, doing that. But the thing I was interested in here was this second one, which is to, if you hold Control and then you click something, it'll copy it for you, or it'll give you the opportunity to rotate it. And that can be useful. So, whoops. So there's that. Oh, this is a point source on the other side. Now we've got a diverging mirror. Is that? Yeah, now we've got a diverging mirror. So we'll do that in the last part of the lab. Okay, so next part of the lab, after you've got the focal lengths of your converging mirror, is to draw a ray diagram. Now, take some time to sketch out good ray diagrams. And there's a table. Let's just go back to the lab here real quick. How do I do that? I go to here. So there's a table that I've given you in the lab, which is this. This is your converging mirror focal length. This is double the focal length, so those are just two values that aren't going to change. And here's the object distance. So we're going to start with an object far away, okay? In other words, greater than 2 focal lengths away. Draw the ray diagram for that, okay? Here's an object at 2 focal lengths away. Draw the ray diagram for that. Here's an object within focal and 2 focals. Draw the ray diagram. Within the focal length, draw that ray diagram, right? So you got 4 ray diagrams to draw for part 3 here. Once you set that up, then go into the simulator and recreate those situations, okay? So what I will say is that this piece here, we're going to do again with the diverging mirror in part 4. So I'm going to skip down to part 4 here. Change your mirror to a diverging mirror and repeat A through C for the exact same situations. Okay? So you're going to do this for both the converging and diverging mirrors. Oops, that's not going to work. All right. Okay, go back to this, show you how to do this. Ding, ding, ding. There we go, we're back here. Now, this is where the object comes in. So I'm going to set my axis. Where's the axis of this thing? Looks like it's about there. So I'm going to pop my ruler. Let's go up one more. I'm going to take my object, put it right there. I forget what the focal length of this thing was. Hopefully it's kind of small-ish, 250 or something, 275. So 500 is that double focal length. 550 maybe. Okay, I'm outside 2 focals right now. I'm going to take a... I can take a beam. This is one thing I can do, is I can take a beam from the top. Oh no. Nope. Wrong one, sorry. I don't want beam, I want single ray. That's what I was thinking. I thought that and I clicked on the wrong thing. So here I'm going to take a single beam, I'm going to pop it to the top of this thing here. I'm going to have it come in straight. In other words, parallel with the axis, right? It's not quite where I want it, so I'm just going to drag it down there. And there is a ray from the top of my object, right? My object being this line right here. Also, what can be useful is to mark where your focal length is. So I can just take another blocker here. I don't remember exactly what it said. It was like 275 or something like that. I've got grid snap on right now, so I'm just going to do that. And now I'm going to do that. And now I can move this thing around a little bit. Oops, not like that. Now I can just move, nope. Now I can just move this thing around a little bit. So I would say maybe my focal length is there. So just as a reminder, where's the focal length, right? You can mark it wherever it is. I guess it looks like it's going to be about there because that's where it's coming through. But don't put it in the way because you're going to kill off your light beam, right? It's actually a blocker object, right? So you're going to say your focal length is there, 2 focal lengths, you could mark that just to give you an idea visually of where things are, okay? So set that up and then choose another ray and choose, this is ray 1. You could choose ray 2, you could choose ray 3. And see if they match your ray diagram. Okay, and now scoot the object in over here to at 2F, and then in between F and 2F, and then at F. Or wait, did I say at F? Hold on. No, I didn't say at F, but I said within F. So, oops. Okay, so outside of 2F, at 2F, between F and 2F, and then inside F. Now, if you want a little bit of funsies, I didn't tell you to put it at F, but you could do that. That would be kind of I should have thought of that. Put that in there. That would be kind of a fun thing. Predict what you think you'll see and go for it. All right, so you'll do that with both the converging and diverging mirrors. You'll draw those ray diagrams. Tip: if you don't want to change this mirror, then, like I said, you can take everything. I can take this entire thing. I think I can take it over here, and then I can grab my little dot right here and have it go the other way, like so. Now, if I just move everything to this side, it's a diverging mirror. Or, here's a cool other thing. Using that menu down here, this help menu, if you click, if you control, you click, and then you click, it gives you this arrow, and then the arrow you can just... that was not what I thought was going to happen. Huh. You can louse everything up. Why did that happen? Oh, it's supposed to be able to rotate it. How come it didn't rotate it? Huh. Whoops. Okay, don't want that. Go away. Alrighty, anyways, if I thought I'd do control this and then I click out in here, I can move it, but I thought I could rotate it. Oh well, I'm not able to do that, but I did it once before, so I'm pretty sure you can do it again. Anyways, you could, in principle, just turn this thing all the way around and then use it as a diverging mirror. Maybe you can work on that because apparently I can't seem to do it right now. Last part of this lab, just to finish this off, is to go to the last bit of part 3 and then calculate using the mirror equation and the magnification. Given an object distance, which I gave you as 1.5 times the focal length and 2.5 times the focal length, where's the predicted value of the image, how big is the image, and then go make it on the simulator and see what the simulator gives you. So if I needed an object at 1.5 the focal length, I don't know where that would be. I don't know, maybe like here. I'd get my ray. I would draw my single ray in, draw my other ray in, find out where the image is, and then measure it with my ruler and compare to what the mathematical prediction was that I made. All right, so I have columns in there for predicted values, measured values, and you can compare with the percent difference between the two. So that is the lab for this week. Have some fun with it. Enjoy it. Play around with it. It's a little bit of a fun program. And please be sure when you do, I recommended doing a screenshot of some parts and doing a like a write-up of some other parts. So when you get it all compiled up, please submit it before the next class period, which is going to be Tuesday. So it'll be due Monday. It'll be due Monday midnight. Alrighty. Please drop that into Canvas when you're done with it, and I will see you back in class at the start of Tuesday. So I'll see you Tuesday either on the class Zoom, or hopefully I will see you, or actually you'll see me on Tuesday. Maybe that's a better way to say it. I forget that I don't see you, but you'll see me. So have a great weekend. Enjoy a little bit of physics with the optics simulator, and we'll talk to you later.